So we're back to chapter 8, and it's still all about short-term decisions companies need to make. This next decision relates to a company when it has a constrained resource. So constrained resource is a limited resource of some type. So we're not able to meet demand because we're lacking of a certain resource. The resource could be time. I think that everybody can understand that one. There's not enough time in the day to do everything we want to do. It could be money. It could be materials or availability of getting materials from a supplier. Could be our labor time or machine time. It really depends on the instance. And there could be several constraints that are there for a company, but we're really going to focus on the worst one first, the bottleneck, which is where we're actually getting stuck, where we'll have a whole bunch coming through and nothing is going out. Nothing's getting completed because we're stuck at this point, or very little is going through. So I like to think of the bottleneck, especially with the 163 and the 5 where they meet. So the 163 north from downtown, where the 5 south comes in, flooding with like 2 or 3 lanes, and then the 5 north comes in with like 2 lanes, and then it like, okay, you're going to shove yourself into 1 lane. Like, that's not going to work. You're bringing 5 lanes of traffic in to 1 lane for the 163, right? And you know there's going to be traffic there. You try to avoid that spot as much as possible because you know there's going to be traffic there. That's a bottleneck right there. If you focus on easing out after the bottleneck, maybe opening up 10 lanes of traffic, that doesn't really help because it may help slightly, but it's not going to change what's happening at the bottleneck. Or if you add more lanes coming in, that would even create a worse bottleneck at that point in time. So your focus is on easing the constrained resource, easing that bottleneck so that you can be as profitable and productive as possible. So in this part of the chapter, we're going to focus on figuring out and determining the most profitable sales mix when you have a constrained resource. So we're going to look at this example, Ensign Company. They produce 2 products and they've given you selected information. So I've rewritten some of the information over here because we're going to use it. The selling price for product 1 and product 2, variable expenses for product 1 and product 2, and then the contribution margin for each. Without any constrained resource, which of these is most profitable for the company based on the number of units? Or sorry, based on the amount that it's contributing to the bottom line per unit.
Product 1.
Product 1, right? Because product 1 has a higher contribution margin per unit than product 2. So if you don't have a constrained resource, you would obviously maximize and meet demand for product 1, and then you would focus on product 2 because it is more profitable for the company overall. But when you have a constrained resource, it might shift. You might not see that product 1 is as profitable in relation to that constrained resource as product 2 is. Current demand per week in units for each product is 2,000 units for product 1, 2,200 units for product 2, and we'll use that in a second. Contribution margin ratio, 40% and 30%, so obviously showing that it is more profitable. Processing time required on machine A1 per unit is 1 minute and a half a minute for product 2. Machine A1 is the constrained resource and is being used at 100% of its capacity. There is excess capacity on all other machines. Machine A1 has a capacity of 2,400 minutes per week. So we're going to do a calculation first. We're going to figure out how many total minutes we need to meet demand for each of our product lines. So demand in units for product 1 is 2,000 units. Demand per week for product 2 is 2,200 units. We're going to multiply that times the A1 time needed per minute, or sorry, per unit. So we need 1 minute per unit for product 1, and we need a half a minute per unit for product 2. So to meet demand for product 1, we need a total of 2,000 minutes. To meet demand for product 2, we need a total of 1,100 minutes. So in order to meet demand for both of our product lines, we need a total of what?
3,100 minutes.
3,100 minutes. And we only have 2,400 minutes available. So we need to figure out how to best utilize and maximize our profit in relation to our constrained resource, our A1 time. Because we do not have enough time to meet demand for both of our product lines that we offer. So there's a few questions that we're going to go through. First question is, how many units of each product can be processed through machine A1 in 1 minute? So product 1, we have a minute of time. And it takes 1 minute per unit. So in 1 minute, we can process 1 unit of product 1, right? For product 2, in 1 minute, it takes half a minute per unit. So how many units can we process of product 2?
2.
2. So it takes less time to process our product 2, right? For part 2, what generates more profit for the company using 1 minute of machine A1 time to process product 1 or using 1 minute of machine A1 time to process product 2? So what we're doing is figuring out our contribution margin in relation to our constrained resource, because this is going to tell us which product line generates more profit per our constrained resource. When we have a constrained resource, this is going to tell us what is most profitable for the company to do, which product line to maximize and meet demand for. So our constrained resource is a minute is our, sorry, A1 time. And we can process a unit in 1 minute here. So it takes 1 minute per unit, and it takes a half a minute per unit for product 2. So we're going to divide our contribution margin per unit by our constraint to figure out how much per minute of A1 time each product is contributing to the bottom line. So $24 per unit divided by 1 minute per unit. The units will eliminate. We'll be left with a dollar amount per minute. So for every minute that we use A1 time producing product 1, we're contributing how much to the bottom line?
24.
$24. So the contribution margin in relation to the constraint is $24 per minute. For product 2, $15 per unit divided by a half a minute per unit. For every minute of A1 time, what amount of contribution margin is being earned from product 2? $30, right? Because we're processing 2 units in 1 minute for product 2 and only 1 unit of product for product 1. So when we have this constrained resource, the time, which of these product lines is most profitable and which we should meet demand for first in relation to our constraint?
Product 2.
Product 2. So we're going to maximize our profit by meeting demand for product 2 first. And whatever's left over, we'll use to create as many product 1s as we can. Product 2 is the most profitable in relation to the constrained resource that they have because the contribution margin per minute is higher. Questions so far, or is it making sense?
No, it makes sense. But are we supposed to do anything with like the 2,400 minutes and like to meet
That's
the
what we're-
demand? Okay, I was about to say, I was like, wait, is that it? Like I thought we had to solve something else.
No, we're not done. We're only on the first 2 questions. Third question is where we're going to get to the 2,400 minutes.
Oh, okay.
So the question is, how many units of product 1 and 2 will the company produce to maximize profitability? So we're going to go over here. And we're going to start with our most profitable product line that we have, which is product 2. And the first line of this is the number of units demanded for product 2, because we're going to meet demand for product 2, and whatever time we have left over, we'll use for product 1. And we'll produce as many as we can, but we know we can't meet demand for both the product lines. For product 2, 2,200 units is our demand. We're obviously not going to go above demand, because if we can't sell it, what's the point of making those products when we have a constrained resource? We're going to multiply this times our A1 time per unit that's required for product 2. So 0.5 minutes per unit is needed to get the total time we need to meet demand for product 2. So 1,100 minutes total. So the sales mix will be product 2, 2,200 units, because we're going to meet demand for that. And now we're going to figure out how many units of product 1 we're going to create. So we're going to take our total minutes available, which was 2,400 minutes. And we're going to subtract out the minutes that we used to produce product 2. So we're going to use 1,100 minutes to meet demand for product 2. We're going to subtract that out. And this is going to tell us how many minutes are left for our least profitable product line in relation to the constraint, product 1. So we have a total of 1,300 minutes available to produce product 1. The next line is the number of minutes needed to produce 1 unit of product 1, which is 1 minute per unit. We're going to take the number of minutes available for product 1 divided by the number of minutes to produce 1 unit of product 1, which is a minute, to calculate the number of units of product 1 that we'll produce. So the minutes are going to eliminate, and we can produce a total of 1,300 units of product 1. So the sales mix that maximizes profit for the company in relation to this constraint is a 2,200 units of product 2 and 1,300 units of product 1. Any other sales mix will be less profitable for the company when they have this constrained resource. Give you a second to write that down. Oops. Does that make sense?
Yes.
We have one last question for this. But I want to give you time to write this down. I want you to think about this question. If additional minutes of A1 time are available, up to how much would the company be willing to pay for that additional minute? So if they're able to purchase additional minutes of A1 time, up to how much would they be willing to pay per minute for that time? Any ideas for that question? How much do you think they'll be willing to pay?
I'm letting it digest in my mind. Hold on. Because I'm not sure if I understand or not.
So you have a total of 2,400 minutes. You've already allocated those 2,400 minutes between product 2 and product 1.
Okay.
But if you were able to somehow buy additional time for the machine, up to how much would you be willing to pay? It can't be an indefinite amount because at a certain point, it's not going to be profitable for the company to buy that time, right? It actually caused the company to have less profit than they already have.
Okay.
For this question, which of the product lines have we already maximized and met demand for?
Product 1.
Product 2. Yeah. Product 2, we've already met demand for. We're already creating our 2,200 units of product 2. So anything related to product 2 is out. We don't need to pay more for A1 time to produce more units of product 2 because we already have met demand for it. Creating more of those units would be unprofitable for the company because we wouldn't be able to sell them. For product 1, we only have the capability of producing 1,300 units when we have demand of 2,000 units, right? So if we're able to buy more time, we want to use that time to produce product 1 because we have 700 units of demand that we can't meet each week. So we would be willing to pay up to $24 per minute for additional minutes of A1 time. Because if we pay exactly $24 per minute for a minute of that time, we'll be able to meet demand for an additional unit and exactly break even. We'll cut into our profit. We won't make any profit on that sale. So if we're able to pay $23.99 for an additional minute, we would make a penny of profit from that additional unit that we sell. Any amount less than $24 per minute is going to provide us with extra profit for our bottom line. Yeah, it's an additional cost. Yes, it will be eating into our contribution margin that's earned. But if we have the ability to pay extra and we can have that extra time, we have demand that we can meet. We'll have less unhappy customers.
Okay, okay. I thought it was some like big reveal calculation in my mind.
Yep, no calculation.
No.
It's already a number you calculated. So imagine if they have like 10 products. Each of them is going to have their own contribution margin in relation to the constraint, and you're going to rank it in order of which is most profitable in relation to that constrained resource. Are you guys ready for a break?
I want to do what the crowd wants to do.
I'm going to say yes.
Okay.
We can do a break.
So I'm going to pause here. So the last decision that a company might have to make is sell or process further. So this is a decision that relates when they have a single raw material input and they have some processing that happens, and they need to decide if they should sell when they have a sellable product or if they should process it further at an additional cost. Usually after processing it further, it's going to provide a higher selling price for that more processed or refined product. So this is going to be common in the oil and natural gas industry, lumber industry, where you have this raw material that you can process and have a sellable product, or you can process it even further and have another product. It's easy as, sorry, to kind of think about it by looking at a diagram. So you have a common input, which is our raw material. And obviously there's costs associated with these common inputs. And at the split off point is where you have your two joint products. So you have two products or multiple products that you're able to sell at this point. Before this point, before the split off point, you don't have anything that you could actually sell. You just have costs that are accumulating. After the split off point, you have, let's say, two products. You can process it. You could sell it at the split off point and have a selling price here for each of the products, or you could process it further and have a more refined product with a different selling price after processing it further. When you're looking at a sell or process further analysis, the only thing that matters are the incremental revenues and the incremental costs of further processing. So is it worth it to process further? Is the profit better by processing it further, or is it better to sell at the split off point without further processing? With that seller process further analysis, you want to ignore the common input costs. So you ignore all costs incurred prior to the split off point, because you need to incur those costs in order to have at least a sellable product. So they're irrelevant to the decision at hand. We're going to look at an example. Sawmill Inc. cuts logs from which unfinished lumber and sawdust are the immediate joint products. So I've started a diagram over here. We have logs, and our immediate joint products are unfinished lumber and sawdust. Unfinished lumber is sold as is or processed further into finished lumber. So we have a cost associated with that processing, and then we can sell it as finished lumber. Sawdust can be sold as is to gardening wholesalers or processed further into Presto logs. Data about sawmills' joint products includes. So we have lumber and then sawdust per log, sales value at the split off point. So for unfinished lumber, the selling price for unfinished lumber is $140. The sales price for sawdust is $40. The sales value after further processing of the lumber is $270. And for the sawdust, it's only $50. Allocated joint product costs. So as soon as you see the word allocated, you know that those are amounts that were not individually or directly traced back to specific product lines, right? Because that word allocated means that it's an indirect cost. These are joint product costs. So the 176 and the 24 is incurred just to have a sellable product. So we know that these are going to be irrelevant to the decision. The cost of further processing. So for unfinished lumber, the additional cost to actually process it into finished lumber is $50. The cost to process that sawdust into Presto logs is $20. By using the diagram, we're able to kind of see what information we should include and what information we shouldn't include in our analysis. What we're trying to figure out is which of our products, or if both of our products should be sold at the split off point, or if they should be processed further, which is going to be most profitable for the company. So we are comparing our incremental revenue or increase in revenue compared to our increase in cost of further processing. First thing we're going to do is selling price after further processing for each product. If we process lumber further, we can sell each log for $270. If we process sawdust further, we can sell it for $50. We only want the increase in revenue from further processing. We already earn $140 at the split off point if we sell unfinished lumber. So we're going to subtract out the sales revenue that we have at the split off point. So the unfinished lumber we can sell for $140. The sawdust we can sell for $40. To determine how much our revenue is increasing by processing these products further. So we're going to subtract the 140 from 270, and by processing those unfinished lumbers further, we're increasing our revenue by $130 per log sold. For sawdust, by processing it further, we're increasing our revenue by $10 per log sold. Sorry. We're trying to figure out the increase in profit or potentially the decrease in profit from processing it further. So we need to incorporate that additional cost. So to process it further, the unfinished lumber into finished lumber, we incur an additional $50 in cost. To process the sawdust into Presto logs, we incur an additional $20 in cost. So processing lumber further gives the company an increase in revenue, or sorry, an increase in profit of how much?
$80.
$80. For sawdust, by processing it further, what happens? You have a decrease in profit, $10. It costs more to process the sawdust further than the increase in revenue can provide. So it actually decreases the company's profitability. In this scenario, would you process both of these further?
No.
No. Which one would you process further?
Lumber.
Lumber. And for the sawdust, you would recommend sell at the split off. With this price point, they would have to sell it at the split off point. If they're able to reduce their additional processing costs or potentially increase the selling price after further processing, then it might be worth it to them to process further. But at this point, it's not worth it to them. It's not profitable. Questions? Who's ready for Thanksgiving break? Who's ready for a week off?
We're short-staffed at work right now, so I'm working probably 6 days during Thanksgiving week, so I'm happy if we don't have class.
Yeah, so you won't have class next week. Yay. Use the rest of today and use all of next week to catch up on any past due assignments. There's no penalty for doing them late. It's fine. Just get them done. We have a late break. Take advantage of it. Email me if you have questions, but I won't be responding as quickly next week because I need a break off. I need a break too. You guys are almost done with this class. You have 2 more chapters. We'll finish up those 2 chapters after the break. Chapter 8 homework is due this weekend, so complete it. If you're satisfied with your first 3 exam scores, you don't have to take the final in the class. So focus on just catching up on the past due assignments that you have. And don't forget to come back to class for the last week or so of class. But have a beautiful Thanksgiving break. That's all I have. And I want you guys to focus on your homework. I want you to finish it off so you don't forget to do it this weekend.
So we don't have class for the whole week next week, Professor?
No class.
Oh,
We get a
okay.
break.
said thank you.
Thank you.
You're welcome. I'll